So I'm Brendan DeRosier. I'm a senior open source developer at OpenCraft.
And I'm Feanil Patel. I'm a DevOps manager at edX.
Right, and today we're basically going to be going over tools and techniques for hosting and maintaining highly available OpenEdX deployments. We'll also go over a couple of examples to see what high availability looks like in OpenEdX, and we'll even go over a couple of fork management tips at the end. So with that, I'll hand it right over to Feanil for choosing your stack.
So I'm going to talk about a couple of different sort of infrastructure choices you can make. You've got lots of options out there. I'm going to concentrate on 2 or 3 just here, and I'll talk a little bit in general about what to be looking for. Before anything else, we'll just talk about on-premise, just because on-premise is awesome, right? You get all the control in the world. The problem is you also get all of the technical difficulties that come with managing all of your own infrastructure from scratch. So there are times when you have to do it, so I just wanted to mention it. It's totally feasible, but you're managing a lot of your own things. You don't have managed services for anything, but if you're working for a company where you need it, or if you're working in a country where you need it, that's your choice being made for you, and it is a choice that we sort of have to acknowledge, right? Next, Amazon Web Services. So this is what Amazon's awesome. It's what we used for edX.org. It has a lot of managed services, probably has the most managed services of the cloud providers out there today. And so it's really great for that, so that you can sort of reduce the complexity of the number of things you have to be concerned about, because you can say, oh, well, I can ask AWS to manage RDS. I can ask AWS to manage Elasticsearch or Memcache for me. So those things will just work, and I still have to watch out for them and monitor them, but I don't have to be as concerned with what infrastructure they're running on or how their clustering is working or so on and so forth. And you get a little bit more help there. Next, OpenStack. OpenStack is what OpenCraft uses for a lot of their deployments, and it's really gets a lot of the same benefits. It's because of the use of OpenStack by OpenCraft, we see a lot more sort of integrations and nice extensions to the platform, because previously, at least the main edX platform repo relied pretty heavily on S3 until there was support added by OpenCraft for just general Django storages, allowing for OpenStack and other things. The other nice advantage here is with either OpenStack or AWS, you know that we've run it in that infrastructure and in that system before, so by the time it gets out to the community, it's already been pretty well vetted. The one downside with OpenStack, the one downside with OpenStack is good luck finding 2 OpenStack providers that are the same. Each one of them is a unique snowflake in terms of reliability, in terms of cost, in terms of just about everything. So while it's a nice standard, finding somebody that meets all of the parts of the standard you cared about and meets all the promises in terms of reliability that you care about, you end up doing a lot of shopping around. Sorry. Other infrastructure providers. There's obviously lots of other infrastructure providers. We could have an entire talk on just all of the possible places you could be deploying your software. But in general, the things to look for is most of them will have sort of the basic abstractions. They'll have some sort of compute. They'll have some sort of load balancer. Most of them tend to have a RDBMS as a service, so you can get managed MySQL in most places. The things to look for when you're trying to sort of differentiate and choose between these is, can you manage things like Mongo? Can you manage things like Memcache or Elasticsearch? A lot of these other satellite services that are part of the OpenEdX ecosystem, but aren't necessarily software that OpenEdX maintains. It's just services that are open source services that we rely on underneath everything else. So here, the differentiators are usually those services, as well as price, reliability, and then availability, where each of them sort of has their own capabilities. With that, Brandon's going to go through a little bit what different sizes and different shapes of stacks look like, and then we'll come back and talk about sort of infrastructure and tools and how to manage and build these stacks.
Cool, thanks a lot, Feanil. So for this first example, I'm just going to take a sandbox and then build up a high availability stack from that. So Here's the Sandbox. We just have one instance, of course, with all of the databases on it, which means that it's just one big single point of failure, which is not ideal. So a step we can take to improve that is to separate out the databases into their own instances. However, this still isn't ideal because we've only added more single points of failure to the stack. We can monitor these things separately now. So the solution to making this highly available would be to load balance between separate edX app instances. So we've added a load balancer there, and also to cluster all of the databases across multiple availability zones. So this way, we can monitor all of the services separately. We can take any single one of these servers out of service, and the application won't come down with it. This is kind of a lot to manage for just having a minimally highly available stack. So how can we maybe take this down a notch in terms of the infrastructure we have to manage? We went from having one server to like 12 instances, including the load balancers. So one of the ways you can do that is to take out MongoDB and RabbitMQ and put those into managed services. However, the cost will increase for this as you basically have to scale up and require more infrastructure. The other thing you want to look out for is the noisy neighbor problem, which causes less performance predictability when you use these services. Okay, and now I'm just going to go ahead and separate out services and add more of the common stuff you would see in a large OpenEdX deployment, just so we see what that looks like. So this is exactly the same diagram as before. I've just refactored it a little bit. And the first thing I'm doing is removing the form service from the edX app instance and load balancing it. And next is to take out the celery workers so we can scale and monitor those separately. And no sufficiently large OpenEdX deployment would be complete without a full analytics pipeline. And finally, I'm adding e-commerce, including the course discovery instances and e-commerce workers. So this is pretty huge. What are some of the ways that we can try to make this a little bit smaller? Well, firstly, we could try to do the same thing that we did before and take out RabbitMQ and MongoDB, but that doesn't really do very much. The percentage of instances that we've taken out of the stack of stuff that we have to manage is very small in comparison to the full complexity of this. There's a couple of other things we can try to do here. We can try to combine some of the services, such as e-commerce and course discovery. We could put those on the same instance by just running the roles. And we could also, for example, take the analytics API and insights and put those on the same instance if you were so inclined. Another thing you could do is, if you're a little bit more creative, is to try to remove some of these load balancers by using kind of a service discovery system, such as HashiCorp Console. Basically, the services would register themselves in the console, and then it would do the dirty work of load balancing all of the services for you via DNS. For a very small infrastructure, you probably wouldn't really want to do this because if you don't have a lot of services, service discovery isn't going to be very useful for you. So if we put this on a small deployment like we saw before, there isn't a whole lot you can actually do with console. So with that, I'll hand it back over to Feanil for managing infrastructure.
Yeah, and so the stuff Brandon's talking about is clearly, as you want to get into more reliable places, you want to essentially start separating your services as much as you can. The cost of that is obviously more infrastructure that you have to monitor. So you're always playing this balance game of which things can fail together versus which things can't. And so he mentioned a couple that sort of are already fairly well coupled. So putting them together, you don't necessarily lose too many capabilities when you're moving back and forth between them. So let's talk about tools. So I'm going to think. The way I like to think about the infrastructure is in sort of two different ways. One is things that change slowly, and the other is things that change quickly. For things that change slowly, think of things like your subnets and your networks and your security groups and sort of routing layers. These are things that once you've defined the topography of your network and your security layers, they're not going to change very often. They're going to change when a service needs to talk to a new service, or when the service needs to, when new services arise, the newer services need new subnets, new infrastructure. But other than that, they don't really change that much. So for things like that, sort of the old way is you build that once, clicky, or like actually setting up the physical infrastructure, you don't touch it, right? With the cloud, the big recommendation obviously is try to write this up as configuration as code. Lots of tools exist now. Most cloud providers have their own tools for this. So I mentioned here CloudFormation. There's also Ansible, which has interaction. It has modules, so you can create Azure or GCE or AWS infrastructure. You can say, make me a VPC, make me a subnet, make me a security group, and you can do it that way. The last one there, Terraform, is the one that I would recommend. It is a cloud agnostic configuration tool for infrastructure. You essentially you define all of the resources that you want and how they're linked together, and it can generate plans for what infrastructure it's going to build, show them to you, and then when you make changes, which is rare, you can see if it's going to need to destroy things, create things, modify things, what attributes it's going to modify. And we'll go through a little bit of an example here of sort of what that looks like and in a bit. For the things that change quickly, there's sort of an incremental step of how you can manage and maintain this. Sort of the step one is what many of you may have gone through, which is essentially you bring up your machines and then you run Ansible against them. Now they're provisioned and they're serving traffic, right? We'll next talk a little bit about Asgard. So with Asgard, we say, once we've configured this machine, we take an image of it, and now we have an image that we can deploy. And Asgard's a tool specifically around Netflix, but the notion is sort of more much wider, which is that you take your images and you can now essentially scale out that image as much or as little as you want to. And then we'll talk a little bit about GoCD, which is a new tool that we've been using at edX, which is a pipeline tool that lets you essentially automate interacting with Ansible, Asgard, your test frameworks, and we'll talk about what that looks like. So start off with Terraform. So Terraform is going to, essentially, you've got your files, you define your infrastructure. That's going to talk to, in this example, AWS. And AWS is going to spit out all your infrastructure, right? So you have, I'm going to go through this a little bit because there's just a lot of stuff that just popped up. So we've got a load balancer, we've got a database, we've got IAM, so all of the permissions that your applications will need eventually in terms of, it needs to be able to reach this S3 bucket, it needs to be able to talk to this API. All of those are defined there. And then any security groups and the multiple subnets and the different availability zones. So you've got multiple availability zones that your application can be in there. And that means that when your application's auto-scaling groups come up, they have multiple places. So you have disaster recovery, both spatially as well as sort of logically. Next, this is where people's sort of paths separate. Once you've got your infrastructure up, you may end up saying, Ansible, build me a machine in this availability zone. You may do it again in the other availability zone and call it a day. Link it up to your load balancer, walk away. The other thing you can do is from there say, hey, now that I have a machine that has all of my applications that are stateless and my databases are offloaded, push that off into an AMI, make an image of that. Now that you have an image, you can start looking at something like Asgard, right? So you can say, pass your image into Asgard. Asgard's going to create a new auto-scaling group, and that auto-scaling group is going to just bring up as many instances as you've said and scale up and down as necessary based on traffic. This is a lot easier to think about because now once you've said this is what the code needs to be, if a machine goes down, a new one comes up in the time it takes for an instance to come up, essentially, in a boot time. So it's about 5 minutes for AWS. For other service, it depends based on your cloud provider. But this is a lot cleaner. It means that if infrastructure falls out, your application doesn't stop working because you've got sort of multiple AZs, you've got multiple locations. So if somebody drives a backhoe through Northern Virginia in one of the AZs, you haven't actually fully lost connection with your customer, right? And then once that new auto-scaling group comes up, you connect it to your load balancer and you're good to go. When you want to do an update, you essentially repeat the process. You connect the new one, disconnect the old one. And so you're in a place where you have very easy rollbacks as well. Whereas if you're doing sort of rolling updates with instances, now you're in danger where like you've rolled the upgrade to all of your instances, and let's say you have 3 instances, as you get to the 3rd one, you finish that upgrade, you realize you need to roll back. Well, that 20, 30-minute process you just take, you now have to do it again and make sure that you hit all of your instances again. So with this, you move forward, you move back easily. It's a lot easier to think about in terms of sort of disaster recovery when you find that like you got an error spike because of some new code that went out. So taking this and sort of tying it all together is GoCD. So with GoCD, what we can do is trigger off of the GitHub repos. It coordinates with Ansible, so it runs Ansible on a machine. It essentially has a pipeline defined that I'll show you in a second, but mostly the concept is you define what the steps are that you take and what the tools are that you need to interact with. And rather than a human doing all of these things individually, you've got a piece of automation that can coordinate the dependencies for you. So it'll talk to Ansible to make the instances. It'll talk to Jenkins to make sure all of our tests have run. And it'll talk to Asgard to actually deploy it once we're happy to deploy it. And so what that looks like is this, which is, and I know it's very small and hard to read, but mostly look at it in terms of sort of the process. So the first column here is doing some pre-testing just to make sure that the Git hashes are all sane. It then moves into this column of three pipelines there, and what that's doing is building for us, it's building our staging and multiple production AMIs because we have multiple production systems that we deploy to. And it's building all of those all at the same time, preloading that work. Then it deploys to stage, and we have a manual step where people can essentially validate their changes on stage if they want to, and if they don't, they can move forward manually. But essentially, we still have that gate of a person who knows what's going on and declares that something should go to production. This is probably something we'll change. I think we're moving closer and closer to sort of fully continuous deploy CI/CD, where we're continuously deploying to production as much as we can. But a lot of that is sort of cultural changes that you'll have to work with your organizations to foster. But once we've got those images built, it deploys to stage, it deploys to production. We've got essentially pipelines where if you need to roll back, it's a click button rollback that any developer can do. We've had issues in production that we discover and roll back without our operations team really needing to think about it, and that's been awesome. So highly recommend thinking about something like this as you want to get to more stable deployments. And with that, I'll hand it back over to Brandon to talk a little bit about fork management.
Thanks, Feanil. So here's some fork management tips and what I'll affectionately call the 4 horsemen of technical debt. These are basically things that I've seen happen in larger instances in the OpenEdX community that you really you want to look out for, because if you don't, then you're probably going to end up with a lot of frustration and time wasted. So the first one is keep your diffs small. And the reason you want to do that is because if you're fast moving, tiny stuff is just going to add up really quickly. And it's much better to pay the cost up front of figuring out what you're going to do to keep your diff small, rather than to pay for it down the road when you do name release upgrades time and time again. Number 2 is Upstream Everything, which is related to number 1 in that this is probably the most important way to keep your diffs as small as possible. And the reason you want to do this is because every time you update, or every time you upstream something to edX, you distribute the maintenance of the feature across the entire OpenEdX community. So what do I mean by that? What I mean is when somebody makes a breaking change against your feature, your tests that you wrote for that feature will fail. They'll have to repair it. And then in that way, They've taken care of maintaining your feature for you, so you don't have to do it the next time you rebase and drag your diff along with you. The other thing is that this kind of forces your architecture and code to be pretty high quality because the edX code standards are very high. Number 3 is don't edit Ansible output, and what I mean specifically by this is not to modify those JSON files that are associated with the various edX services. The reason is basically that these files have an ever-changing schema that's determined by the applications that they're configuring, and you probably want to use the Ansible configuration management that edX is using themselves because by necessity they have to keep up with the ever-changing schema of these files. They update the configuration management as new things are added and stuff is changed. So you can be sure that you'll always get pretty sane defaults whenever you do a name release upgrade. And the other thing is that these JSON files may not always be the destination of the configuration. There's nothing saying that these JSON files won't eventually be deprecated and then the YAML files will be the standard, for instance. So if you use Ansible configuration management, edX configuration, then you won't have to deal with this down the road. Also, don't modify the code settings directly for the same reasons that I was mentioning before. You really want to keep your diff small, and you really want to do your configuration and edX configuration.
Plus, it's just a terrible idea.
Yeah. Okay, so number 4 is avoid template overrides at all costs when you're working with custom themes. You kind of have to do it sometimes, but it's really in your best interest to keep it to a minimum, because every single time you add another template override, what you're doing is essentially adding another chance that when you do a named release upgrade, those templates are going to break because the context getting passed down to the template from the view is going to change, and you're just going to get 500s when you visit those pages. And the real killer is the fact that when you fix this, you're probably going to have to copy the template over again and rebuild the changes that you made into it from the beginning. So you're just doing a whole lot of extra work. And it's important to try to keep that to a minimum. So with that, we can take questions.
Right. And the one thing that I'll mention is that there's a bunch of links at the end of these slides and more details on the various tools that we talked about that will get shared out on the Confluence wiki later. We just wanted to leave extra time for questions. So Florian, yeah, go for it.
Point that you made on your last slide. Okay, so avoid template modifications at all costs. Yes, we know they suck, but what's your alternative?
The alternative is to try. The question was, oh, I guess the microphone is there. Okay, so so the alternative to doing template overrides is to try to make the modifications by basically overriding the SAS as much as possible, because that will tend to break less than the actual templates. The cost of fixing the SAS is still not very good, but yeah, it's not good, but it's probably better than having to copy over HTML that you modified and then having to basically rebuild the feature again, because templates change in complicated ways. Because new context can be added and removed and all of that stuff. So you basically would have to rebuild the entire thing rather than modifying overrides.
There's also that many of the templates are macro templates, so they really contain Python code. It's not only the context change, you're really copying Python code from the platform to your.
Right, so that's a good point. So Sven said that basically, because they're Mako templates, you're not only copying just HTML, you're copying a bunch of Python code as well.
So, and depending on okay, and depending on what you want to do, it might also be worth it to just if it's
like a feature you want to add to the templates, you can think about upstreaming that feature, and then it will be maintained by the community.
Sven, you're on.
Thank you.
Thank you for your awesome work. There is one caveat on the that I'm unable to solve at edRock. Is that how suppose that you have your own server vars that you put on Ansible on the right place. So let's say prod.yml that overrides the default configuration. So one variable got deleted or got renamed. How am I supposed to keep up with that without reading every diff? This is a really difficult problem.
Okay, well, you can jump in if you want to. One thing to look out for is if you're following like named release upgrades, for instance. There are release notes that come out with every name release upgrade, and you can probably catch a lot of stuff from those. Also, there are there's a changelog that's maintained in the configuration repo that I encourage you to keep up with because it will save you a lot of time when you're trying to figure out these things.
Yeah, so one of the things, as Brandon mentioned, is that the changelog in the configuration repo, we're trying really hard that whenever we change the names of things or whenever we're removing or adding new, especially removing configurations and changing and renames, we try to get those logged in there. So if you're doing a diff of just that file across the two versions, you should be able to get a pretty good idea of what those changes were that will break that kind of configuration.
Pass it behind.
Once you're running on an AWS system, but you're doing it all manually, and you want to move to Asgard and you want to move to Terraform, so what would be your suggestion to ramp up that development and not having to light on fire Amazon and then build it again?
Sure. The big thing is that when you get into this infrastructure as code and into this like image-based deploys, you end up actually burning down your infrastructure and bringing it up a lot more, right? So that sort of becomes more a part of the problem. But like for say you already have all your networks and subnets already defined, and you want to now move into a place where you're maintaining it in code and getting it reviewed and all of that. Terraform in particular is a really great resource for this because you can actually import existing infrastructure and map it to files. So now you can say, I already have this VPC imported, I already have this subnet imported, and define it all, essentially get all the definitions for the things that already exist. And then from there say, for these things, we're no longer making changes manually, we're only making changes here. It's definitely not easy, but that's a nice way of sort of transitioning. And it's actually what we're doing because a lot of our infrastructure that isn't new existed well before Terraform was Twinkle and HashiCorp Psi, right? And so we have a bunch of infrastructure that we've slowly been importing ourselves so that we can start managing it. Because like the infrastructure we have managed this way, so much cleaner, so much nicer. It's a lot easier for us to know when people are making changes, what those changes are. When things break, it's a lot easier to localize to, oh, this infrastructure and this code change are what did it, right? So, but yeah, I think the import feature is a really great feature of Terraform if you're thinking of moving that way. And then once you have the infrastructure that's not changing that often imported, then you can start thinking about the image-based stuff, which can be either layered on or can be done independently.
So I took a look at the infrastructure you described, and there was this reference to specifically the AWS databases, right? Mm-hmm. So my big question is, how does that account for GDPR, right? This is coming up. This is the EU requirement for hosting data, right? Because it seems like you're pointing to one virtual construct and communicating with that versus routing user data to specific regions. So how does that get counted in the infrastructure?
Right now it doesn't. So Django itself does have a lot of routing capabilities, but right now the application itself isn't very sort of student region aware, right? So this isn't a thing that we've been thinking a lot about, unfortunately, and we will have to deal with. But like, I wouldn't say I have a very good answer for it right now. In terms of the underlying technologies, I think the technologies already exist. But in terms of like how we're going to actually implement this, I think there's going to need to be a lot of code changes to make more parts of the system aware of locality, like what the locality of that data is supposed to be, and then try to make that happen. So
yeah, it would be great maybe if the platform is going to help in that direction,
right,
that we start getting some indications of that, because the data is known.
Right.
There's a deadline. They've already published it, and it's coming up, and there are huge penalties behind that.
Okay.
So, you know, for us, we're starting to look at, you know, design considerations and stuff, and it'll be good to align those things if there are changes or help coming from the platform side.
Yeah, I'm not fully aware of the deadlines you're talking about, so maybe we can talk offline,
Sure,
and I
we
can
can
get
do
more
that.
information and
Okay.
take it back and make sure we're all on the same page.
That's fine.
So I think at Stanford we've learned a lot of those mistakes as far as reducing the diff, that delta between upstream. And so while that's good advice, I think it to a certain extent it's idealistic to the point of being impractical. One I think just the tidbits that we've learned, I think that help the most with that though, is you're gonna have to change things unless you land everything upstream, which you won't. But really what makes a difference is just not modifying those things inline. Move everything to external files as much as you can, and then import in. So then worst case scenario, your conflict resolution is just, pull in our customized thing here.
Sure. So another thing I would also emphasize is that even though it is kind of idealistic, the reason that I sort of said, you want to upstream everything is because that's really like the goal in this. And I think that it actually is kind of possible if you have like a really strong communication with edX, and when you're thinking about upstreaming a feature that might be controversial and not necessarily useful for everybody, then it's important to open a channel of communication with edX very early and see what you can do to get it into the code base, right? And put it behind a feature flag or something.
I hear you. Let's take it offline.
Okay. Any more questions?
I just have a couple comments really quickly. First of all, one is that about this issue of theming and customizing the Sass or the HTML or so on. We believe this is a really hard problem, and we're very interested in solutions to this about how can we make theming more maintainable in the future, especially as we look at edX changing its front end to Bootstrap 4 and React and so on. That's going to break everyone's themes all over again. So I'm really interested in hearing from the community in the future ideas about making themes more maintainable. The other thing I just wanted to say is that a big advantage of upstreaming everything is that only the latest named release gets updates from edX and security updates in particular. So if you're running on an older release and you have a huge diff, you are at a big risk for security vulnerabilities and so on. So that's one reason that we like to upstream everything, because then we can upgrade to the latest named release in like a week or two. And if you don't do that, then you have to really watch out for security vulnerabilities.
Thanks for that commentary, Braden. Are there any more questions?
Yeah, I would like to talk about you said that now modify the JSON files, the output of the Ansible, but sometimes we don't have enough configuration in the server bars about the configuration repo to be to have the variables enough that you need. So is there a path for you to work on this?
Yes. So I've run into this situation a lot of times myself, where I want to configure something in OpenEdX, and there's just no variable override for this thing. It's just kind of it just defaults. What I would recommend for that is to upstream that override in the edX configuration repo. I think you'll actually find that it's quite easy to do this. The change to do this is like 3 lines of code and change log, and also Feanil and the DevOps team at edX are really good about merging things like this very quickly.
Yeah, because we're going to miss configurations that we try to think about as many of them as possible, but sometimes developers put in new configurations that don't get wired all the way through. So we welcome any of those changes, and we will try to take them as quickly as possible. I know, Julia. I will review your stuff today. All right, I think we are out of time. Thank you all for coming. Please enjoy the rest of the talks.